stage is yours. You know best what you're going to talk about. So,
well, let's hope. Of course, cool to be here. Thanks for joining us today. We want to talk about security operational technology and why the year-long neglection of such technology created a bomb that is about to go off. Hopefully, that's excited enough for you.
So, OT is one of the most emerging cyber topics at the moment, and it should be on the agenda of everyone. We are going to talk about 3 points. So we're going to talk about what OT is, how it is being attacked, and how we can secure it. And just quick mention, we work for Deloitte. I'm Jasmin Rubin. I specialize in operational resilience and cyber threat intelligence, and I have a background in foreign affairs and intelligence.
Yeah, and I'm Jan Freudenreich, and I also work for Deloitte in the cyber department, specializing in the security and resilience of critical infrastructure. One quick question, actually. How many of you have ever heard of OT, of operational technology, in a security context? We got 1. 2.
2?
Nice.
That's good.
It's going to be exciting.
Hi.
Welcome.
So let's start with what is OT. So OT is generally defined by controlling physical assets, so machines, processes, industrial equipment. So an example would be a robot in an assembly line or an insulin pump in healthcare. In other words, OT is the IT stuff for industrial computer systems, and it is the backbone of our society, so to say. It's processes that run 24/7, and you can see it's important. They're very difficult, expensive, and hard to upgrade, and the equipment is sometimes very old, so you can already see the problem. The usual way of securing like IT system just doesn't work here. This results in highly vulnerable environments, and we can see that we don't want highly vulnerable environments in energy, defense, healthcare, mining, food and beverages, manufacturing. It's just the risk is very high. The stakes are high, let's put it like that. Maybe a quick visualization, and let's go back in time a bit. So it used to be 2 different environments. So it was the IT environments dealing with data and flow of information, and the IT experts. And then we had the OT experts that dealt with all the operations and the processes. And there was not a lot of exchange. It was kind of like an air gap between those 2 environments. And that made the OT environment less prone to cyber threats because the accessing those environments was very hard before. Over to Jan.
Thank you. So, as Jasmin mentioned right now, these are specific systems. So you can imagine these are not the same systems as you would see in your IT environment. Something that operates a water treatment plant or a chemical plant is usually not the same as your laptop or general server. These are very specialized systems. So, for example, as I mentioned before, there's 3 different things usually for these systems. They are very customized, usually to one specific thing they should do. They are quite expensive, and they should run 24/7. So interruptions are usually nothing that you want to see in these kind of areas. So the usual way as you would secure your IT infrastructure often does not work in an OT world. That's for example, as we talk about IT, you usually know what's going on in your network, especially for stationary devices. In an OT world, this is often not the case. You don't even know actually what kind of device is operating in your environment. If you look, for example, at access control, you usually have personalized accounts in your IT world. You have SSO, you can centrally manage and revoke credentials and access rights. In the OT world, you often have default credentials, even supplied by vendors for the whole global infrastructure. And also for detection, in a modern IT environment, you will find endpoint protection solutions, XDR, you find network behavior monitoring, all these kind of things. In an OT world, this is generally really hard to implement. Because if you don't want to use your availability of your devices, it's really hard to upgrade and exchange them. It's contradictory to the point of the impact, actually. If you look at the IT world, obviously there could be some impacts on people everywhere, but it's usually very indirectly that people are harmed through an IT incident. If you look for the OT world, this is not the case. Usually people or the environment, for example, let's talk about a chemical plant. If something happens there, personnel or people in the vicinity that could be really in danger. Also, the environment could be harmed. If you talk about healthcare infrastructure, obviously, if this device doesn't work properly, people are in danger. That also brings us, I hope you can see it in the below. I don't know if everyone is from the secure field, but there's three tenets of cybersecurity, basically. It's called the CIA triad: confidentiality, integrity, and availability. In the IT world, you have a lot of variants. So obviously, confidentiality is commonly in the modern world an important driver, but you also find systems where you need availability or integrity as your most important topic. In the OT world, it's generally the case that availability is what you're looking for. Because of the mentioned fact previously, availability is king in these kind of environments. As also Jasmin mentioned previously, there have been two separate worlds. However, now they're moving together. This should be a quick visualization. This should be a common modern industrial environment to produce goods. Let's say this is a car manufacturing site or something. You will find a plant operator. They usually take care that everything is working properly, but they also communicate externally today. They communicate to the enterprise environment to make sure that, let's say, someone orders goods, that they are produced in that way. But also, you will connect to a cloud computing instance, usually cloud services that provide data analytics for your processes. You will have inside a factory, you find your autonomous or semi-autonomous machines and robots. They produce the goods, in this case, probably they're putting windows in your car. And they are remotely managed, often by third parties, for predictive maintenance. You find a lot of IoT devices, smart devices that could monitor your environment, look if everything is proper, but also autonomous robots, which basically bring resources from one production line to the other, that everything runs smoothly there. And then outside of the factory, you have your connections to other factories, you have connections to vendors, basic supply chain management. Well, this obviously is really cool in a digitalization way. This is interesting. You can bring your development in your society to the next level there. However, all these points that I talked about are obviously also attack points for malicious actors.
So yes, I think Jan started the conversation. What is the problem when IT and OT are converging? So all what he just said leads to a convergence of the two, and that leaves an open playing field for malicious attackers. We assembled some attacks that happened quite recently, actually. So if we put in the title a time bomb that is about to go off, let's be clear. I think the bomb has been going off for a couple of years already. So Iran's entire train system was shut down because of an attack on IT that led to an OT outage. So the entire train system didn't work anymore. There was an attack on a petrochemical plant in Saudi Arabia that only didn't lead to an explosion or anything worse because there was a mistake in the code. So a security control was triggered, but that was sheer luck. Then there is groups, APT groups, Chimera, trying to get intellectual property from semiconductor vendors in Taiwan. Also, the tech didn't reach its full potential. Again, lucky. And I think the one that is the most interesting to me is the Florida water plant incident, where through remote access, unsecured remote access, attackers were able to get into this plant and tamper with the OT equipment, and they did raise like the level of, let me check, because this is chemical now, they did raise the level of sodium hydroxide to dangerous levels, and only an employee who was vigilant enough realized it before something happened. So another question is, why are people able to lift these levels anyway? So that should be implemented already, but then again, those near misses just show that what Gartner says. Gartner considers cyber attackers being able to harm people or kill people in 2025 by OT attacks, and that's in 3 years. So you can see here already it's getting really dangerous and really close misses. And we are going to talk about 2 attacks later in detail. But first, let's talk about how the OT threat landscape is actually being attacked. So the number of attacks is rising. We did put together some numbers. There was a survey, and 80% of participants said that their OT environments experienced a ransomware attack in 2021. I mean, that's 80%, that's astonishing numbers. 90% of OT organizations experienced at least one intrusion in 2021, and 60% 3 intrusions or more. And the increase in vulnerabilities that solely affect critical manufacturing is rising, is going up to 213% compared to 2020. So you can see this are numbers that should not be ignored and should be on everyone's agenda. Let's quickly get into motivations of hackers. Financial gain, I'll start with that. Common attackers are ransomware as a service groups, non-state sponsored actors, we call them, but they're also sometimes a bit close to states. Well, you know, Darkside, Revel, Dharma, Lockbit, etc., and they want money. They sometimes also have different motives, and state let them disrupt other states, of course. Then we have the political and strategical disruption. Those are state-sponsored advanced persistent threats. This is the Chimera one I talked about that attacked the Taiwanese semiconductor vendors that wanted to steal intellectual property. Those two are both state actors. So the first one would be one who wants to disrupt, for example, a railway system in Iran. That was actually probably a group within Iran, but still that could be a state actor. And then the theft of intellectual property are actors who want to, get the code or get semiconductor intel. And they focus on high-tech and life science industries mostly. And then how do they get access? Unsecured networks, remote access that is unsecured. Physical, I'll get into that in a second. Phishing, of course, is very common, also spear phishing. And insider threats, so a malicious insider who wants to gain money either, or is a disgruntled employee who just does it because he doesn't really like his own company. Okay, let's get into Stuxnet. I don't know how many of you are familiar with that. Oh, wow, probably. Oh, wow, a lot. Great. So feel free to jump in. So Stuxnet was called one of the first, or the world's first digital weapon, 2010. And I'm not going to get super technical. I'm just going to go through the attack that happened in Natanz, in the uranium enrichment facility. So how the worm, got in is actually very interesting. So it was an infected memory device, and so far experts are not really sure how it got in. And there's a lot of intelligence behind this, so there is always speculation when it comes to attacks like this, because governments don't really like to disclose those informations. But we know that it was an infected memory device that got into this air-gapped environment. Stuxnet, computer worm, did embed itself, and then it began infecting the computer systems, and there were no security alarms because the system, the system was able to exploit 4 previously unknown zero-day vulnerabilities, which is quite a high number. Stuxnet then searched the system for programmable logic controllers by Siemens, and it targeted those computers that had those systems, and they enable computers to interact with the uranium centrifuges. That was the end goal of the worm. Yes, I think most of you know what happened. OT got messed with, and the centrifuges, they spun irregularly over weeks, which resulted in 1,000 to 2,000, it's unclear how high the number was, centrifuges being destroyed, which, of course, also the security question here, very lucky nothing happened except centrifuges getting destroyed. The Iranian nuclear program lost a lot of money, of course. It was set back around 2 years, experts said. And what I find most interesting is that the worm escaped. No one knows exactly how, because it was supposed to be an air-gapped system. It did infect 100,000 computers approximately in 2010. Well, nothing really bad happens to your computer unless you get like the screen of death, of course. But since your computer is not connected to one of those centrifuges, nothing should happen. And I think it was a Belarusian group who found out about who discovered the worm essentially. So just very geopolitical-wise, super interesting. Okay, I think.
Yeah, we also prepared a second example, one more recent. I think also everybody heard, at least in a political sense, the attack 2015 on the Ukraine power grid. That's an example we took here. Again, this was started by a phishing campaign, as most attacks are. Basically, attackers, they targeted suppliers for the energy grid and got access to multiple locations. Then they moved within those networks. It took months for them, which is quite common for APTs, for often state-sponsored attackers, to do it low and slow, to not be detected for a long time, to reconnaissance all the whole network. And then after getting access to domain controllers and to credentials, they finally got access to a VPN, connecting them to the OT network. Then, which is actually quite remarkable from a skill perspective, what they did, they started reconfiguring devices. Basically, they rewrote firmware for serial to ether connectors and to other devices that could actually open beakers or disrupt the power supply within plants, operated terminals. They prepared that, and then when the time was right for them, it was around Christmas, I think 23rd, they started the attack, first by denial of service attack on the call service agents, to just people that don't have energy, they want to know what's going on, so they are also disrupted. They cannot get information from their companies anymore. Then they used that reconfigured firmware, installed this on these devices, and rendering them useless, opening the beakers to the energy grid, and disabling remote connections for operators, so they could not remotely change the system again. And then as a third part of the attack, they used the kill disk malware to wipe all the disks within the plants and the operator terminals for two reasons. Basically, the first reason is obviously that hinders the recovery time of the operators, but also to destroy forensic evidence in the end, to make it harder to identify how the malware moved through the systems. And the consequence was that 230,000 people were without energy. But most importantly, such attacks, they don't always only look for the direct consequences, but also to create some kind of mistrust or destabilization within a region or a particular area. Well, the question is then obviously, what can we do to prevent such things from happening? Which brings us to the next area. Maybe a quick insert. What we are actually doing with these kind of things in our usual work, we try to understand cyber risks for companies, for governments, or for everybody that's involved, with the goal to raise the resilience of these environments that we talked about. So we go in, we do an assessment of an ecosystem. We usually take the role of an attacker to take the mindset of an attacker, to find weaknesses in the system, and then restructure that system so that in future it cannot be exploited in that way, or makes it even harder for that. What we identify usually are very common security challenges. Most importantly, when we look at OT, we have very insufficient network segmentation. That allows a lot of these attacks to happen, or the impact is greater to these attacks. Basically, that one IT system is connected to another OT system, and there's no separation going on. No vulnerability management is also a very common cause. As you can imagine, if you don't know that your system is vulnerable, it makes it way harder to protect it. Obviously, inadequate access control. Previously, I mentioned that you will find in OT environments often shared passwords within the whole factory plant, or even default credentials from vendors, which is in today's security architecture usually not the way you should do this, but let's keep it like this. And I think often overlooked is also, of course, the people. What you often find is also a lack of awareness in the mindset, especially in these environments that has been operating for 20, 30 years without anybody interrupting. And that hinders security efforts in the long run.
So what can companies do to make a difference? It starts with visibility. So if you don't know there is a threat, you will find out once the threat is inside your company. So it's good to know the threat landscape and put that into context when you talk about security in your company. So, for example, if you're a Taiwanese semiconductor vendor, you should know that some state-sponsored APT groups are interested in your knowledge and might attack you. And just having this worldview and this visibility and intelligence in mind helps you secure your systems. Then Second of all, prevention. So as Jan already said, network segmentation, managing vulnerabilities, system hardening, etc., and especially the restrictive access controls, that is key to securing your OT's environment. A lot of those attacks actually did happen through remote access controls that were not secured and credentials shared with a lot of employees. That just can lead to disaster. Responsibility is one thing we see a lot. There needs to be a clear operating model within the company and roles need to be assigned. If no one feels responsible for security, it can get neglected. And as Jan said, if it's 25 years it has been working, then you just assume it's going to work forever. But we saw the numbers and they look not very promising. And then last and not least, the right mindset is key. So we suggest adopting a post-breach mindset. So not think if it happens, think when it happens. And have some crisis management and disaster recovery in place, because this can actually make the difference between having a couple of rough months and being essentially bankrupt. Or worse, in OT, as we learned, can lead to loss of life. So I think we've actually already reached the end. Quick recap. So I think you could remember these key points. OT is everywhere, including the critical systems at the heart of our society. It's the backbone of our society and runs 24/7. It's very hard to upgrade, or let's say harder to upgrade, and it's often insecure, and that makes it a valuable and somewhat easier target for attackers. And attacks are on the rise, as we said, and it can have a significant impact on people and the environment. And the motivations for actors include financial gains and state interests as theft of intellectual property or just disruption. What companies can do and what we help them do is having a clear responsibility structure, starting with visibility and trying to prevent attacks, but also think about what you do if the worst case happens. And yes, I think we have some QR codes.
I think that's the important part. I think now you have a lot of time to ask questions because you're actually faster than we expected.
Yeah. Okay.
And also in the long run, if you also want to get in contact, please add us somewhere, contact us, or afterwards meet us for coffee. But please, if you have any questions to the things we said or want to know more about some specific topics,
or about Deloitte, or about any other cyber topic we can try to answer, feel free. And as always, you can add us on LinkedIn and pop up questions later. I mean, we're going to talk back to you.
Even better.
Maybe I can start the question. Have you ever been directly involved in a life-threatening situation?
Yeah, we obviously cannot mention any specifics, so I keep it, especially as it's recorded now, joke aside. Well, what could happen, for example, say like this, if you do an assessment, let's say it like this, in an environment where you have autonomous robots. These are really old. And if you start, I don't know if you're off from the security field, I should have asked at the beginning. So security knowledge level is, let's say, otherwise you asked. And you start trying to map the network, you try to understand what the system does, you run your scripts, you run your nmap or whatever you have. And in the IT world, usually you get an answer or not, or nothing happens. These devices, they sometimes act, well, in a way that you would not expect. So you always have to make sure that they are completely isolated from people. Let's imagine, for example, a robot arm that you ping with a request and it starts just going off because it cannot handle a ping request. If people are around that area, that can be quite dangerous. Which also makes assessments, at least from my opinion, in these areas quite interesting, because you really have to think on another level, not only the general IT security, but you also bring in the safety level too.
From a technology point of view, what can you actually do to prevent OT attacks? You said you just prevent them, but what can you actually do? I think that was this part, right?
Mm-hmm. The prevention of attacks. First, network segmentation, that usually what we see when you look at the network architecture in the beginning, that you will see already, okay, where's communication happening? Where should communication not happening? If it's not possible to communicate with another area, you will most likely not have an attack happening that easily. Yes, obviously.
Connection, so you would say and recommend just don't do it.
No, that's not the case. But you have to understand how you segment and segregate. I agree. But it's a very good question. Yes. Because this is the problem. This is coming together. So the networks also have to communicate. But you have to restrict that communication. You have to bring in, usually you bring in gateway devices, which handle security interactions. And what is now happening, for example, is, I mentioned before, detection and monitoring, which is not as easy in these environments. What's happening right now, what we see a lot happening is that we bring these kind of devices, specific prepared monitoring devices in OT environments. So usually vendors, they provide passive network monitoring, because I mentioned earlier in the example, active monitoring, if you start sending around packets in your environment, can be quite dangerous or disrupt the process. So what they do, they analyze the traffic, they understand what's going on. They also give you options to reconfigure, but most importantly, they give you a first possibility to perform a threat analysis. If something changes rapidly in a network, you understand there's something going on. You will hardly have automated procedures, as you would have in IT world, because in an IT world, sometimes you can just shut down something, you can just contain it. It's really dangerous to do that, because there could be, again, people's life in danger. Or also just keeping it on an easier profile. Let's say it's a company producing something. If that production line goes down, sometimes it takes a day to get that production going. That's also a lot of money. So you don't want to, even if it's not for safety concerns, you just don't want to do that just because there could be something. But that's something that's happening right now.
Quick question. You had some numbers on attack counts on the previous slide.
Yep.
Where did you get them exactly from, or how were they measured? Because they seem really...
They're extremely high, yes, of course. No, that is not a representational number as in every OT company in the world, but there was a survey and 80% of the companies, I think it was 1,000 companies that got asked or something. So it is, yes.
You can find it online. It's a survey from 2021 from SUNS, together with a security vendor that you will also find in there. And yeah, they also mentioned the factual numbers we just presented here. For example, the 213% increase, I think it's an increase from 65 to 230 vulnerabilities.
Yeah, something like that.
Yeah. So Google for SUNS OT survey.
So there was not, I mean, in the ransomware attack, it didn't specify whether people paid, etc. But we hear about ransomware attacks every week, basically, and most of ransomware attacks get unnoticed. So most companies don't really want to publish that they've been ransomwared. So the numbers, I mean, they're still quite high, but we see ransomware attacks happening every week, and also in Switzerland. So it's quite a common problem, actually. And as said, in OT environments, this can be even worse than in IT environments when we look at people's lives in the environment.
And especially if you look, for example, in the intrusion, as you mentioned, an intrusion doesn't mean that something is completely destroyed. It means that someone got access to something in your network. In most cases, that just doesn't result to anything or detect it before something happens. In an IT world, you can take that risk easier because usually your systems are more secure. If an OT world an intrusion happens and you see a 30, 40-year-old machine being just connected to something, then you really want to also hinder intrusions more than an IT world.
Yes, I see.
Yeah.
I guess let's...
Well then.
Do you have another question?
Please shoot. There's a lot of time.
Yes.
I'd like to ask you also about maybe more about you're from Deloitte, right? What are you actually doing in your everyday job?
Go ahead, please.
A little bit more precise information.
Sure.
Yes. I think I'll start. You can do the OT stuff later.
Yeah.
So I work mostly in operational resilience. That means we look into companies' important business services. Okay, let's imagine we're looking at an insurance. An important business service is helping their clients when they have a car breakdown, like something that is very important for clients. Then we map those processes, and that's where the IT part comes into place. And we look what systems are underlying, what systems are important, and we're always looking at it in kind of a what happens if we have a total loss of IT? What happens in that case? How can this insurance or this bank or this whatever company still supply their customers with this important business service? How can we get it back up and running? And then we test it, and we try to kind of help them figure out their, as we said, this post-breach mindset. So we kind of, in my projects, I usually help clients with their post-breach management, whereas we have other projects where we kind of help to prevent incidents. I mostly deal with companies that want to know what to do once it happened, because companies are aware that that can happen any day. And we do see with some clients that had a breach that they get up and running again. But if you don't have plans and you don't even know what your important business service is, then it's chaos. It takes months, and some companies go bankrupt. So that's kind of what I do. Then we do some cyber recovery projects.
I'm from a technical background. I'm from a network security background. Studied also informatics, not here, but in Munich. Then started as a penetration tester for Deloitte. And then moved to specialize a bit further into the OT world. So what I then did most of the time was doing assessments in OT environments, often manufacturing sites, to understand how secure is the network, how secure are connected applications, how secure is, for example, hardware or autonomous devices or IoT devices. And then, again, also together with the other teams in Deloitte, there are a lot of different specialized teams, understand how you can actually help these ecosystems to be more secure, both from a technical perspective, but also from a procedural perspective. Then we have then both sides going on there.
Yes.
So your slides say there's been a 213% increase in vulnerabilities in 2021, probably compared to last year.
Yes.
Why has there been such a huge increase in 1 year? Like, what has changed?
I think, sorry if I take it.
I'm like a tech guy.
I think there's a multitude of reasons. The first thing being that if you look at the number, you will see that, how I put it nicely here. First, if you start looking for things, they pop up more often. You will also see that in other things. So it started to become more a research topic. That's the first important thing. So these numbers are going up. The second thing is what we mentioned is the IT and OT convergence. So it's more and more stuff happening, more and more attacks are happening, and more people are installing their OT environment together with IT environments. They're starting to use internet-connected services. They start to use cloud manufacturing, all these kind of things. That attackers are becoming more and more interested in these environments. If you look 30 years ago, for example, your OT infrastructure was not connected to the internet. As an attacker, it would not be easy to get into, or basically impossible to start doing something there. Now that you connect this, people start to become interesting and see the effects that other attacks, as we mentioned, Stuxnet, as you mentioned, the Ukraine power grid hack, we didn't mention, but Triton, for example, in Saudi Arabia, an attack on an oil rig, and then also attackers, ransomware gangs, or state-sponsored threat groups. Well, they become more interesting. They see that it's possible, and they go into more research and try to find more vulnerabilities that later pop up also on our radar. Also, what you mentioned, ransomware groups. As you know, for ransomware, a lot of the companies or people, they start paying because it's, well, you really need to go, it's your system back, you want your data back. If you imagine you take down a oil rig or something, the value is quite high for that company to pay something or do something. And that also creates, sadly, a big incentive for malicious actors to go into that kind of research.